So welcome everybody. My name is Kevin Fleming. I work for Bloomberg in New York. I've been a member of the open source community, project leader, contributor, etc. for a very long time, 20 years or more. And so what I'm going to talk about here, first of all, this is not a technical presentation, unlike almost every other presentation at CppCon. And we're actually not going to dive into the mechanics of open source licensing, for example, or any of that kind of stuff. Although if you are interested in that sort of thing, I have an open content session at 8:30 tonight after dinner where we'll actually do exactly that, talk about how licenses work and what you need to understand about them, how they affect you as a developer, how they affect you as a user and a contributor and all those other things. So this talk is really about a very brief history of how the open source movement came to be what it is, why it's important to us and to the world, and how you can participate in that. It's generally focused on encouraging people to contribute to open source projects, to learn how to do that, to better their skills either as students before they've graduated college, or even as people who are currently employed as software developers but have only ever worked on proprietary projects. So any of you already contribute to open source projects? Just a couple of hands. Are any of you students in college? Yeah, well, okay, cool, yay. So good, then that means this will be relevant to a lot of you, and you probably have not heard this history stuff. So let's start with, and we only have a small group here, so I won't push too hard on this. This is supposed to be a little bit of audience participation here. So this slide is supposed to have 5 words or phrases on it, I guess they're all words, that sort of embody what open source means. Anybody want to volunteer a word they think that should go up on the slide? Well, there are wrong answers. I won't say there's no wrong answers. There are wrong answers, but you probably won't say anything that's wrong. So anybody want to say anything? If not, I'll dive in. All right. So let's start with the most obvious one, which is sharing. The open source movement is about sharing things. And you'll notice that I am not specifically talking about open source software here. And you'll see about halfway through the presentation why that's the case. But this is generally about sharing things that have been created. There's a lot of reasons for that. A lot of motivations for people to share things. It could be because they want to make the world a better place, for whatever that means. It could be because they feel they'll gain some recognition, maybe an ego boost or some reputation increase or something else by sharing something that they've created that other people find interesting or valuable or novel or innovative or something along those lines. So there's a lot of motivations for doing that. And the next part of all of this is what happens when it goes beyond just one person who has created something and wants to share it with the world. And now there are other people who want to help that person continue to improve that thing, whatever that is, whether it's, let's say it's software, because that's an obvious example here. So you write something, you publish it on some website, you throw it up on GitHub, whatever. People come across it, and suddenly you start to receive emails or pull requests or whatever mechanism, and people say, hey, wow, this is really cool. I use this software that you wrote. It's awesome, except I really wish it did this. Would you make it do that? Because that's what they usually say. They don't usually come along with a patch to make it do that. The first thing they usually say is, hey, would you make it go do this? So you might have not ever thought of that. You might have thought, well, okay, actually, that's an awesome idea. Sure, I'll go spend an hour, and I'll make it do that, and I'll put a new version up there. Great. So now you have cooperative development. It's not just you anymore. It's multiple people who have actually helped to figure out what this thing is going to be and how it's going to grow in the future. And if the thing you've created is something that's of really broad interest and attracts a community, you'll end up with a lot of that, which means you'll end up with a lot of people asking you to write code for them for free, which is the way all open source projects work. But if you're really lucky, you'll start to get people who actually contribute in ways other than just sending you bug reports and asking for new features. You'll get people who actually start to give you enhancements to the software. And obviously that's one of the really major motivating factors of publishing this kind of stuff in the first place, is that you want other people to be able to help work on it, to help improve it, and not it all just be on your shoulders and your ideas. So this, of course, is the biggest part of the, let's say, the growing phases of an open source project. If you imagine infancy and then maybe being a teenager and then becoming a young adult, and eventually you get to some mature place where a lot of large projects are. This is sort of in that young adult phase where, you know, the software's got a lot of people using it, and maybe now there's a bunch of people contributing to it. And it's started to become important to some audience. There's some community of people who find this thing that you've published to be important to them. They started to build systems that rely upon it. So it's no longer just a toy that they're experimenting with, but they've actually used it in ways, probably in ways you didn't even realize that people would use it. And so that means now, as a good steward of this project, you have to start thinking about the future changes that you make to that being a collaborative effort. It's no longer just your decision about what the next things to do are. If someone comes along and says, wow, this is great, and I really wish it did this, and here's a patch that does it, and you go look at it, and go, well, So the way they implemented that, I don't really like very much. It doesn't fit very well with the way I wrote the rest of the software. But the idea they've got seems kind of sound. I don't have the time to go rewrite their patch myself. I'm going to have to encourage them to work on getting their patch into a form that I'd be willing to accept it. Now you get collaborative development. It's no longer just them giving you ideas and you going off doing the work, but you're actually working together to write things. You might not both be writing code in the patch, but you're at least working together on that. So this grows, project gets bigger. Maybe you've got, I don't know, pick a number, 50 people, or maybe if you're really lucky, 100 people now who are in some form contributing actual work to your project, code, documentation, tests, whatever that might be that they're contributing. And this becomes a bigger and bigger project, and more people are paying attention to it. More and more people are relying on it. And so now you find yourself in this situation, which all open source projects find themselves in, which is there's got to be some mechanism of leadership, some sort of governance, some way for decisions to get made. If you're all software people in one form or another, you're all fully aware that all of us that write software have opinions. We generally have very strongly held opinions. Sometimes even in the face of facts that completely disprove our opinions, we still hold those opinions. And so when there's a discussion, to use that term very generically, about how something should be done, it can very frequently reach an impasse, where you've got three people, all of whom are respected, experienced developers, three different opinions about how the project should go forward. Someone has to decide. Otherwise, nothing happens, and you obviously don't want that to happen. You want your project to move forward. So as projects grow, and this of course happens in open source projects and also in closed source projects, somehow there has to be decision making. Now there are major open source projects that I'm sure you've all heard of, Linux, Python, a number of others, where there's one person. There's one person who really has the final overriding say on whether this is the way we're going to do it, or that's the way we're going to do it, or we're just not going to do this thing that you want to do at all. Now, they certainly listen to the community. They have constructive discussions usually. There's lots of documents that go back and forth talking about how things might be done, and maybe some code gets written to experiment with whether it actually works or not. But at the end of the day, that person makes the decision. We're either going to do that or we're not going to do that. There are lots of other projects where that's a group of people. And unlike, let's say, commercial development, those people weren't all hired. Nobody went out and said, hey, we need leaders for this project. Let's go hire 5 people who are really experienced and we'll make them the leaders of this project. In an open source project, things don't work that way. People gain that status of being considered to be a leader of the project because of their contributions to the project's community, which could be code, it could be helping users who just start using it, it could be writing tests, it could be writing documentation, it could be talking about it at conferences, all kinds of different things it could be. They gain recognition through their work, not by lobbying, not through politics, usually, not by the fact that they happen to be employed by a company who pays them a lot of money and maybe that company also sponsors the project or whatever. Generally speaking, this is the way people attain this status is through their value to the community. And we use the term meritocracy for that, which is a fairly apt description. You achieve that level of recognition through merit, things that people find valuable that you did. So you think about all this and go, well, so if all of this is happening, why would somebody do this? I mean, clearly you had someone originally publish the software. Maybe they just wrote it on a weekend and thought it might be interesting for the rest of the world. But 2 years later, it's become this big project with thousands of people who are using it, maybe an unknown number of people who are using it, which is usually the case with open source software. Lots of people contributing to it, and it's become, people that you've probably heard the phrase, don't ever let a hobby that you have become a job. You start to make interesting things on the weekend, and then you sell a few of them to friends, and they say, gosh, you should sell these at the craft fair. And then you go to the craft fair, and now suddenly 400 people want to buy those things, and your hobby has turned to this something you do every weekend, all weekend long, and it's no longer fun. This happens in open source software too. You get involved in these projects for a variety of reasons. Part of it is you are personally motivated. You want to improve this software, whether it's because you use it or you don't use it, but you think it should be better and you have the skills to make it better, or whatever that is. There's some motivation that's causing you to want to do this. And as the burdens of participation grow, hopefully they don't grow too much, but they're going to naturally grow. At some point, there's going to be these discussions about how the project should go forward and when should a release be made. And no, that patch you just contributed, that's awesome. We'd love to have that feature, but we're trying to get version 3 out the door and we're late and all of this other stuff, and it's just going to have to wait till next year. Those kinds of things are obviously demotivating. You wrote this code because of some personal desire to see it exist and the project to be improved, and well, okay, it's not going to actually happen until 6 months from now. Why would you keep doing that? You're not being paid, usually, to do these sorts of things, and things are happening that aren't under your control. Well, passion. That's usually what drives this. People have some innate reason that they want that project to be better than it was when they found it. And that could be because they use it and their company's paying them to improve it. It could be just because that's an area of interest that they've had their whole life, basically, their whole adult life, and they just want that thing to be better. It could be that the project serves a purpose in some community that they're affiliated with. For example, there are a number of open source projects that the tools that come out of the project are targeted at making it easier for a lot of charitable organizations to do what they do. So maybe you have some personal reason why you would like to see the Red Cross be successful in whatever it is that they're doing, and they're using some piece of open source software to do something that they're doing, and you think that's a way you can contribute. You can make that piece of software better so that they can do their job better. All of that leads back to you have some reason to do that. So there's a super high level overview of what gets people doing all of this. And then the end result of this, which I'm going to go to the next slide because this is a word with many, many, many meanings. You'll see the word free used in the free and open source software world a lot. It means a lot of different things to a lot of different people. It means different things in different projects. Some projects have a very philosophical desire for the things that they're producing to be free in every sense of the word. So free as in they don't cost you any money, free as in you're always free to use them in any way that you like and to modify them and distribute them in any way, and free even to the extent that if you should choose to do that, if you should choose to modify the software and distribute it further, the work that you've done will continue to be free. That's one whole chunk of open source projects and licenses work in that way. And there are others that aren't quite so philosophical about that. There's been a very interesting, actually only the very beginning of a discussion, I guess on Twitter and a couple other places today and yesterday. How many of you have heard about the episode, I guess it was Friday, that the EPA announced that they found that Volkswagen had put this weird software in their car to make it notice when it was being emissions tested and change the way the car behaves so that it would pass emissions tests, but then when it wasn't being emissions tested, it would go back to its normal behavior, which is the behavior that the customers actually wanted out of the car. But anyway, people are saying, well, guys, guess what? If the software that's in the computer in that car, even if it wasn't freely licensed, even if the only thing that was available was the source code was available for inspection, but you didn't have the tools to rebuild it, you couldn't put a new version of the software in your car, you couldn't modify it and redistribute it, even if the source code was just available for inspection, there's a really good chance they never would have tried to get away with that. Because there's enough interested people out there who would have gone and looked at it and someone would have said, hey, this is not supposed to be doing that. And so that's another aspect of software being free. is that you can look at it in a lot of different ways, but one of the ways is that you're free to ensure that the software does exactly what it's supposed to do. If you're motivated enough to do that, you can do that. So let's talk about a little bit, a very, very brief history. The history of all this goes back to when computers really first started. So obviously we're not going to cover all that because that's a lot of time and a lot has happened. But for those of you who are interested in this sort of thing, if you go, you can go find the very first computer program that was ever published. And the very first computer program that was ever published was written by Ada Lovelace, and it was a program for the Babbage machine, which hadn't even been built at that point. It was only a design. And that program was published in a scientific journal for anyone to look at. Anybody who got a copy of the journal could look at the program and study it and inspect it, and conceivably they could have published other versions of it if they wanted to, although that wouldn't have been very practical then. So the very first program that was ever written that we know of for a computer, which was actually written for a computer that it couldn't even be run on yet, was itself open source. And that was actually true for a number of reasons up until, I think, the early 1960s in the US anyway. Prior to that point, software wasn't considered property. The work that programmers did, which we all believe to be creative work, just like writing music, writing books, doing sculpture, lots of other things, wasn't considered to be copyrightable material. It was math, basically. You were just writing down instructions to make a big machine do a bunch of mathematical operations on some data and produce a result at the end. Now that changed, and there's a debate. People say it could be good for bad or good or bad, but it was determined that yes, in fact, software does qualify for copyright protection. But prior to that point, there were computers. Now there weren't hundreds of them. There were more like dozens of them. Maybe there were hundreds of them by the time that those decisions happened. They certainly weren't the kind of thing you had in your house. They certainly weren't the kind of thing you carried around in your pocket. If you were lucky, you went to school at a university that had 2 or 3, and maybe you worked at a company, a big company that had a few of them. These are, the pictures you've seen from a long time ago, refrigerator-sized machines with computing power that's just we wouldn't even consider it to be a computer today compared to what we have. And yet people were doing useful, productive work with these machines. They were writing software to solve problems that they had, and they didn't think of the software as property. So if you imagine that some student, let's say some graduate student at some university, is studying, an example I like to use, let's say studying aerodynamics, airplane wings and airfoils and all that kind of stuff. And prior to having access to the computer, for those of you who are old enough to even know this, and there may not be anybody in the room who is old enough to know this, prior to having access to the computer, if he or she had a large series of calculations to do to determine whether a shape of a wing would produce more or less lift than some other shape, what tools did that person have to do that? Anybody want to venture a guess? Slide rule, that's exactly right. So they would do long, drawn-out series of calculations using slide rules, which you can imagine is not only slow, but it's very error-prone. Because if you make a tiny mistake somewhere in this big chain of calculations, the rest of it's just trash. So you had to be slow because, well, otherwise you could make a big mistake. So having a computer where you could write down all of the sequences of instructions that needed to be done to all of these different variables to come up with a result, and then run that over and over and over again and ensure that every single time the exact same steps were followed, amazing. I mean, it's just a huge improvement in the ability of people to do these things. So someone would go write a program to do this. And then maybe they would publish a paper about some breakthrough that they discovered through the use of this program that they had running on this machine, and that paper would get published, and maybe they'd go to conferences and talk about it. And somebody at another university who read the paper would say, man, we have a computer like that. It would be awesome if I had a copy of that program, because then that would help me in my research. So they would maybe call or write a letter to the person who wrote the program, because of course we didn't have computer networks at this point, and say, man, it would be really awesome if I could get a copy of that program. Would you give me a copy? And they'd say, sure, send me a tape, or whatever mechanism it is that our computers use for loading and unloading programs. And so I don't have to, bear the cost myself. Send me the stuff and I'll put a copy of it and send it back to you, and boom, you have software sharing. So someone created something that they found interesting and useful. Someone else found it useful and wants a copy of it. And great, you've got sharing of software. So this happens because people want to share the result of their work. Same thing we were talking about before. So this goes on for quite a while. Computers start to become much more common. Certainly not still in homes yet. And the time frame of this slide is maybe the 1970s, early 80s. So, pretty much every major school's got them. Lots of companies have them now. There's actually an industry of making computers for sale, and lots of companies do it. There's even, to some degree, an industry of making software for computers, that someone goes and buys a computer from the manufacturer. It comes with an operating system and a bunch of stuff on it, but then they also go to other companies and obtain software for it. And there's an industry of making peripherals for computers, like printers and terminals and modems and other things, so they can talk to each other. So there's this anecdote, which you're welcome to go read more about, but I'll give you the very encapsulated version of this. Any of you heard of a man named Richard Stallman? Yeah, one headshot. Okay, so his name is out there. Richard Stallman was a student, graduate student at MIT, I believe, and working in the artificial intelligence lab. And in the artificial intelligence lab, they had recently received from Xerox the first, which may have been the first ever, laser printer. It was really a photocopier that had had some stuff added to it so it could receive data from a computer and generate stuff on paper directly, as opposed to it having to be printed out in some other form. So prior to this point, people used dot matrix printers and band printers and other kinds of printers, but there were no laser printers then, or some inkjet printers either. So they got this printer, and everybody goes, wow, this is awesome, because now I can print out my 20 pages of code, and it'll take 2 minutes instead of half an hour, and plus the, whatever, lots of improvements. But as all printers do, it has printer problems, like it jams. All printers jam, right? Everybody hates this. And he ran into this situation where he sent a job to the printer, went a couple hours later to go retrieve his printed job from the printer, and it wasn't there. And actually, the only paper that was in the tray was somebody else's print job. And turns out there's a red light flashing on it because it's got a paper jam in it. So this whole time it's been sitting there, hasn't printed anything. Now, today, none of us ever experienced that, because today, if you connect to some printer, whether it's physically attached to your machine or you're talking to it over a network or whatever, and you send a print job to it and it's got some problem, like it's out of paper or it's off or it's offline or it has a printer jam or whatever, what happens? You get some kind of pop-up on your screen that says your print job's not printing because the printer is out of paper or whatever it might be. Well, this didn't exist then because people didn't have that sort of thing. It existed, but not in that same way. So he said, hey, I've had this problem before. At a previous place where I was a student, we had a different kind of computer and a different kind of printer, but we had the same issue that you would send stuff into the print queue and it wouldn't get printed and you wouldn't know about it. And so what he had done was he went and got the source code for the driver for that printer and realized that the printer actually had an electrical signal that told the computer whether it was printing or not. So he modified the driver to watch for that, and if the signal said it wasn't printing, then the software would actually send a message back to all the people who had print jobs in the print queue and say, hey, the printer's not printing. If you want your stuff printed, you're going to have to go one of you is going to have to go figure out what's wrong. Huge improvement, right? It's a productivity improvement. He says, I've done this before, I'll do it again. So he goes and looks for the driver software for the printer that they just got, and it's not there. It's not on the machine. Now, keep in mind that we've actually gone through this big cycle where when you got computers back then, all the software that ran on the machine, the source code for all of it was also on the machine. That was just how they were delivered. The operating system and all the drivers and all the tools and everything just came on the machine. For those of us who use Linux regularly, we're used to that now too. I mean, it may not all be pre-installed, but it's one command away, and all the source code for anything that you've got running on the machine pretty much is there. It's almost all open source. Obviously, there's also lots of systems where that's not the case, where you don't get the source code. Windows obviously being a prime example, and lots of other things. If you've got a copy of Microsoft Office or Adobe PageMaker or whatever, you don't get the source code for those. But the natural assumption at this time was that if there was a piece of software running on your computer, that the source code would be there too. So he goes and looks and goes, somebody must have forgotten to give us the source code for this, because we always get the source code for everything. It's not there. So they contacted the people at Xerox who gave them the machine and the printer, and their reply was, no, you can't have the source code. And he was stunned. why? Why can't I have it? I mean, it's the driver that's driving the printer that we got from you. Why would you not give me the source code? And their response was, it contains proprietary intellectual property. We don't want to give that away. And of course, at this time, they were making the very first laser printers. They didn't want to enable their competitors who also made photocopiers to get a jump start on making competitive laser printers. So that was their motivation for doing this. So we can understand that, at least from capitalism running a company point of view. But he was very frustrated by this, and he was especially frustrated by it because for those of you who ever worked on such things in operating systems before, if you're going to go produce a driver for a hard drive, or a driver for a scanner, or for a printer, or for a graphics processor, or whatever, you don't write it from scratch. You take one that's already there, that does something sort of similar to what you want, and then you modify it until it does what you actually want it to do, and then, yay, you've got a new driver that does that. Well, they'd done the same thing. They took a driver that already existed for that machine and modified it until it worked with their printer, and then compiled it and gave everybody the binary, which means there was software in their driver that they didn't write. And yet, he couldn't get a copy of it because they had wrapped it all up in this kind of thing. So, being the man he is, and if you're interested, there's lots and lots of things you can read and watch videos about him. He's a very, very strongly opinionated man. He said, this situation shouldn't be allowed to exist. Not only am I upset that I have this one particular situation sitting in front of me where I know how to solve this problem, but the only way I can get it solved is to convince Xerox to go make the change for me and then eventually get me a new copy of the driver and get it on my machine, and eventually this problem will be solved. I don't want this to ever be possible, ever. So he did a number of things. We published a manifesto called the GNU Manifesto, which formed the GNU project, which eventually spawned the Free Software Foundation, all of which was built around this philosophical idea that it should be possible to produce software, give it away to people, like I talked about in the very first slide, but ensure that it could never become unfree, which isn't a word, but it makes sense in this case. That you could never reduce the freedoms that the person who gave the software to you gave you in the first place. You could not further push it on to other people and not give them the same level of freedom that you had. So that's one of the things we'll talk about in the session tonight, is there's a license called the GNU General Public License, which was written specifically for this purpose, to give software authors the ability to say, I'm going to publish this, give it to the world to use as they see fit, under the condition that no one can ever take away that freedom from anybody else. So this was a watershed moment. This really was the first time that anything like this had happened. As you may very well be aware, there are some very, very significant open source projects that use that license, Linux kernel being one, and lots of others. So, all right, so now we have these pockets. We have some open source software development happening, but it's not a global worldwide phenomenon like it is today. And this is, let's say, late 80s, early 90s, maybe getting towards the late 90s, especially in the case of Linux. Yeah. What's beginning to happen is people are noticing that some of these open source projects are attracting large numbers of developers, not just large numbers of users, which you'd expect because the software does something interesting and useful and it's free, so obviously there's going to be people who want to use it, but they're attracting large numbers of developers, people who are skilled, experienced, they're helping the software improve at a very rapid pace. They don't know each other. They don't work in the same office. In the vast majority of cases, they've never even met each other. They've only ever interacted over email and IRC and other forms of electronic communication. And yet, this methodology that's sort of growing organically in this community is producing very, very good software. And it's getting better at a pace that's accelerating more rapidly than other ways of building software. So there's a couple things that you can expect then as a result of that. The software, first of all, the more people you have, and this is a quote from Eric Raymond, which is another interesting book called The Cathedral and the Bazaar, which you may want to go read, that going back to that example of the VW software, If you have more people looking at it, there's a greater likelihood, although certainly no guarantee, but there's a greater likelihood that problems will be found before they become actual problems in running the production of the software. We all know this today because we do lots of code review and lots of people can see the stuff that we're writing, and hopefully whatever processes we write software on a regular day-to-day basis encourage this sort of thing. But that wasn't always the case. Lots of large software projects inside companies, not open source projects, there'd be a big meeting, people would decide what the requirements were, they would break up the software into the work into a bunch of tasks, and they'd say, okay, there's 5 tasks, the 5 of you are going to go work on those. You have until this time, and maybe there's some requirements where you have to make sure that your pieces are going to interact with each other, but you were off on your own, writing your own thing. And then at the end, someone called the integration manager gets to try to mash all this stuff together and hope that it does what it's supposed to do. Well, that was not the way things worked in the open source world. Every time someone wanted to make a change for whatever reason they wanted to make it, suddenly you had all these people who might not even be people who are contributing software. They're contributing code review. They're contributing architectural review. They're contributing user experience, like, oh, please don't take that feature away. You think nobody's using it, but actually we're using it, and this is what we use it for, so please don't take it away. All that kind of stuff. So, as you can imagine then, as this gains more notoriety, it starts to be noticed, like there's actually articles in the press about it, and the software that's being produced out of some of these projects becomes very important in a lot of ways. So companies, which of course, generally speaking, companies exist to produce value to their shareholders or some definition like that, although there's also nonprofit companies and charities and all kinds of other things, they start to notice this and say, well, if this way of writing software produces better software at a more rapid pace and it's more responsive to the user's desires and needs than the way we've been doing things before, then we should look at doing our software this way. Even if the software we're writing isn't something we're going to give away for free, even if we're going to sell it and it's going to be under a proprietary license and all that stuff, we should still look at the way this is happening, the way these people are interacting with each other. So this has dramatically changed the way software is written inside large companies, and well, actually companies of all sizes. And a lot of companies, especially companies that started within the last 10 years or more, they've never written software any other way. Everything they write, except for a very small bits and pieces here and there, is just visible to every developer in the company, and you can go look at anything you want. And if there's some other part of it that interacts with the code you're working on that has some flaw or you think should be improved, you do it. And now maybe you don't get to commit the change directly yourself. You might have to send a patch to the team who owns that and say, by the way, I think your module would be better if it worked this way. But it's hard now, even for those of us who lived it, to imagine where you couldn't do that, where everything was all of these boxes. So that's one aspect of the way this has affected the way software development is done. But lately, let's say within the last 5 years, certainly, this has become a tool for companies to demonstrate their technical capability and leadership. And it's also become a tool for people who want to be employed writing software to demonstrate their capability and to some degree technical leadership. So you'll see, for example, there's lots of companies at this conference, my own included, or the one I work for, I don't own the company, who publish software that they've written as open source software and contribute to open source projects and contribute to them in big, meaningful ways, like actually adding large pieces of new functionality and helping to provide technical direction for the project, all that kind of stuff. Now, we have a lot of reasons for doing that. Some of them are purely, they benefit us. We want the software to be better, and so we need it to solve problems for us, and we make those better. But by publishing those things and interacting in that way, people who are out there who are skilled maybe in the use or development of that particular project or in that arena notice that. And when they're looking for a place to work, they go, wow, that company's really been contributing a great deal to whatever it is. Let's pick Apache Hadoop or some other major, very popular tool. And of course, that company becomes a company on their short list of places they might want to go work. It's great for that company because now they have attracted people who have common interests in working on that piece of software, hopefully have skills already doing it. It's fabulous. So that's a good thing. It also is a way for companies when they are looking to hire people to be able to see what that person's done before, especially for those of you who went through, let's say, a computer science degree program. Do you think any of the software that you wrote while you were in school was ever seen by anybody else except the people in your class? Probably not. It's not even available, and if it is, it's probably not something you'd want to show to a potential employer anyway. So unlike, say, an artist, where an artist goes to apply for some job, let's say it's an illustrator, somebody who illustrates work in magazines. Well, what's going to happen when they go apply for a job? They're going to take a portfolio with them and show all the work they've done in the past, the variety of work, and what's applicable to the magazine they're applying to work at. Wouldn't it be great if you could do that as a software developer? You could point to things and say, yeah, I worked on this for 3 years, and look at how this improved this way, and that's phenomenal. That's an incredible tool to be able to demonstrate your capabilities and your experience. So that was some very high-level stuff. We're getting down deeper here. So now let's think about what sorts of things, in addition to the fact that computers existed and eventually the internet arrived and a bunch of other technological things, there are a number of really enabling factors that allowed this sort of thing to happen. Now the first one's, kind of obvious because this is about an open source talk, but there's a lot of software for which the source code is not available. So even if you use, let's say, pick an example, you use Microsoft PowerPoint all day long, every day in your job. Heaven help you, that's terrible. But let's say you have to do that every day, all day long in your job. And you are a person who can write C and C++, but for some reason you're creating slide decks all the time. And there are things about PowerPoint that don't work the way you wish they could. You probably wish they would, and you probably have the capability to change that. If you only had the source code to be able to do it, you could do that. Now, of course, if you're sufficiently motivated, you could go try to get a job at Microsoft and work on PowerPoint and eventually get it to be able to do those things. And that's certainly an avenue to pursue that passion for making that piece of software better. So having the source code available is the number one thing. The number two thing, so if the source code is available, but you can't build it, well, okay, you can study it. But you can't experiment on it because there's no way for you to turn it into something that you can actually find out whether your changes were effective or not because you can't build it. Or if you can build it, but you can't get it onto the hardware. Let's imagine lots of things like cell phones, for example, many of which have locks in them so that it isn't possible for you to install your own version of software on them. Even though you can go recompile the software and probably run it on an emulator, for example, on your computer to determine whether the changes you've made were successful or whatever it is that they were supposed to do, you can't actually put it on your device. In some cases, you can maybe get around, circumvent things and stuff, but it's cumbersome. So not having the tools to be able to actually do anything with the source code is almost as bad as not having the source code. Not quite, because at least you can study the source code if you have it, but you can't go beyond that point. And then the last thing, I won't say this is an exhaustive list, but it's certainly three very, very important things that make this phenomenon possible. If you have the source code, you have the ability to build it, you have the ability to run it in whatever environment it needs to be run in to determine whether it does what you want it to do. But that process takes a long time. And long could mean a very different thing for one person versus another. But for example, have any of you ever built one of the open source browsers, Chromium or Firefox, from source code? It takes a long time. I mean, like hours. On a fast computer, it takes a long time to build them from source code. There's a lot of code in there. It's very complex. So if it's going to take you, let's say, 3 hours to build a version of the software that contains the changes that you've made, to then determine whether those changes did what you want them to do or not, and we all know that they won't. There will be something else you have to change, or you did something wrong, and so you have to do it again. This is the typical compile, debug, test, whatever cycle. If that cycle time is 3 hours or 4 hours, or heaven forbid longer than that, and you're only doing this out of passion, you're not being paid to do it, it's only something that you're just, how quickly is your passion going to dissipate? it's going to go away pretty fast because you're going to go off and do something. Even if you just say, well, all right, fine, this is going to have to compile for a while, I'll go do something else. Well, the something else ends up being going out to dinner and a movie with your family, so you don't get back for 5 hours, and it was actually done building 3 hours ago, but you were off doing something else, and eventually you just, screw it, I'm not working on this anymore. So the ability to be able to experiment with changes to the source code of whatever the thing is fundamental to this. So a lot of that applies to software. Anybody want to, and I know this I've covered a lot here, but anyone want to hypothesize another area where having the source code for some broad definition of source code and free tools and the ability to experiment rapidly has produced some other kind of industry or affected some other kind of industry? All right, let me show you one. 3D printing. So the ability to describe a 3D object in source code form. Now, I'm using that term very loosely, but you can describe this chair in math, right? It's a bunch of curves and lines and points and a bunch of other things. All of that can be described in probably a source code file that's only, I don't know, a couple hundred kilobytes at most. It's not a particularly complex thing to be able to describe from an abstract point of view like that. And there have been tools to let you do computer-aided modeling and design for a long time. Now, of course, the first ones were not free. They were AutoCAD and lots of other things. They're very expensive and required very big, powerful computers. That's no longer the case. There's lots and lots of them. There's free, very cheap AutoCAD. There's open source tools. There's all kinds of other things. So you have the source code for the chair, or in this case, this beautiful T-Rex head. And you have tools that would let you go modify it. Great. But if you can't experiment, if you can go modify the model, but there isn't any practical way for you to turn that model into an actual object, like we take source code for a program and use a compiler to turn it into something useful, well, then your passion for modifying whatever that thing is going to dissipate really quickly because you can't even render the very first version of your changes. It's just not possible. That's changed. It hasn't been that long. 3D printers have not been, 3D printers have actually been around for a while, but they were room size and horrifically expensive and incredibly slow. That's, of course, no longer the case. You can now just order off the internet any of dozens of different kinds of 3D printers. They print in different kinds of materials, plastics and metals, and I've seen chocolate printers and all kinds of things. And they're not particularly expensive. Now, they're certainly not free. You don't get 3D printers for free. But when you can buy a 3D printer that's capable of producing that in your home in, let's say, an hour. I don't know how long it takes to make that, but probably an hour is probably not that far off for a moderately good 3D printer. And that printer only costs $400 or $500. If this is something that you're actually passionate about working in, that's a very achievable thing. You can decide, I'm going to go spend $500 to get one of these things because it's going to let me experiment with this. So we have those same three things, right? We have source code because we have these files. I mean, look at what the button says. Download this thing. You can't download a head. You can download the files that describe it, though, and that's good enough if you've got a printer that can render those into some actual physical object. So you've got the source code, you've got free tools, you've got rapid and relatively low-cost experimentation. So now that means you can experiment. Now, you may not be motivated to experiment with something like this. Maybe you are. Maybe you're really into dinosaurs and you really like to have lots of plastic dinosaur heads around your house and you want to make them all different, whatever, that's fine. But if you go to this website, you will see that there are tens of thousands, maybe hundreds of thousands now, of designs for objects that are utilitarian. They're not just decorative things like this. They are, somebody had, the example I've used before, a coffee maker, right? The plastic handle for the pot broke. And they really like the coffee maker, even though new coffee makers are really cheap. Everybody knows that new coffee maker, standard drip coffee maker you can go to Target and buy for $20 or whatever. They're just ridiculously cheap. But we're engineers. We don't like to do that. This one is perfectly fine. It just needs a new handle, right? So you have a 3D printer. You've got a computer. You got some basic idea about how 3D modeling of things works. And just on a curiosity, You go to this website and you do a search, and lo and behold, someone has uploaded a file that describes to a printer how to make a replacement plastic handle for your coffee maker's coffee pot. Wow, score! I'm now going to spend all weekend saving myself $20. This is what we do, right? So you download the file. You go to print it. The first one comes out and you go, wow, this is awesome. And you go try to put in your coffee pot. It doesn't fit. It doesn't fit because one of the mounting holes is in the wrong place. Man, you're frustrated. Except you're an engineer. So how are you going to solve this problem? Are you going to stop and go spend $20 for a new coffee maker? No, you're not going to do that. You're going to say, I can fix this. I know I can fix this. I've got the software to fix this. So you open the file in some editor and you move the hole over to the place where it needs to be. And because you have a 3D printer, you can have another one of those printed in half an hour to see if it fits or not. And of course, it doesn't. You didn't quite move the hole to the right place, or maybe it needs to be a little bit bigger too, or some other minor tweak. And after 2 or 3 times, you get it right, you've got a new handle, this is awesome, and what are you going to do? You're going to go back to this website, and you're going to upload the new file and say, hey, I fixed this for coffee makers that were made between 2008 and 2012. The original design doesn't work, you need this revised version, because you think it's awesome that you did this. What have you just done? It's exactly the same thing as doing open source software. It's just not software. It's a design for a physical thing, right? Same process, same motivations, same tools, well, not the same tools, but a little bit farther afield. Anybody in here not used Wikipedia? Please don't raise your hand, because that'll be embarrassing. How many of you have ever used physical encyclopedias in your life? Good. There's some people that are old enough to have done that. Because every time I ask that, it gets a smaller and smaller percentage. So if that's something I'm going to have to say, how many of you are aware that physical encyclopedias existed at one point in history? So they used to exist, right? And for those of us who were old enough, they were what you had in the library, or maybe you were lucky enough your family had a set in your house, or whatever. They used to sell them door to door back in the Dark Ages. And so you would get assigned some project in school to go research something. And what would you do? You'd go open up the encyclopedia and you'd start learning about it. Great, that was a wonderful resource because we didn't have the internet. There was no other way to do this unless you happened to know someone who was an expert in that field. Your expert that was available to you was books. That was really what you had. And the encyclopedia would be where you started. And then if you needed more in-depth information, you'd probably go to the library and find books written specifically about that topic, as opposed to the half a page that you might have found in the encyclopedia or something like that. So that's great, except how often are things wrong in a reference book? Pretty often. It happens a lot. I mean, they're written by humans, and things change too, right? I mean, it turns out that information was thought to be accurate at the time that it was put in the book wasn't actually accurate. Well, if you've got encyclopedias that were printed 5 years ago, some significant, not now, imagine 30 years ago. So you have encyclopedias in your house that were printed 5 years before that time. Some percentage, possibly a fairly significant percentage, of the entries in that encyclopedia contain factual errors. They just do. People made mistakes, or the life has changed, or whatever. Could you fix it? You could write it in your copy, but it doesn't help anybody else. You may have gone and done 5 hours of research to find out that that was wrong and to get the correct information, and yet you couldn't share it. In addition, they're expensive, they're heavy, they're cumbersome to use because, of course, searching through, 3 bookshelves full of encyclopedias for something where all you know is a few words that might be relevant, it's almost impossible. So, of course, we have Wikipedia. Wikipedia is the world's internet encyclopedia now, right? It's where everybody posts information about everything. So let's go through those 3 things again. So how many of you have ever edited a page on Wikipedia? Anybody here? Got 1, okay. So you can answer this question for me. What's the source code for a Wikipedia page? It's text with markup, right? You click edit. It's right there in your browser. You have the source code. Boom, our first bullet was covered. What kind of tools do you need to edit a Wikipedia page? Internet connection, computer with a browser, the ability to type, read and type, which may not even be a keyboard. Maybe you can't type and you use dictation. I mean, there's a lot of different ways that could be accomplished, but all those tools exist, and they're either free or very low cost. What's the experimentation cycle like for editing a Wikipedia page. Don't think about the moderation part yet, but just making a change and determining whether the change that you made satisfies your desire for the page to be different. Seconds. Maybe less than seconds, depending on how good your internet connection is and how fast your computer is. So those three things are, man, we've got those in spades. It's free source code, it's free tools, it's extremely rapid experimentation, which means if you're interested in some topic area, and this picture I took months ago, I looked today, and the English Wikipedia is really close to 5 million articles now, I mean, within a few thousand of 5 million. So those 5,000 articles were not written, or 5 million articles were not written by one person. They also weren't written by 5 million people. Obviously, they're written by some number in between those. But if you go look on Wikipedia, and if you're interested in a particular topic, I've used an example before of, let's say, for some bizarre reason, you are really interested in French cars, like Renault and Citroën and other French car brands. No judgment on whether you actually are or not, why you might be. Now, you know that if that's the case, you're one of a select group. There are not hundreds of millions of people in the world who share your passion for those cars. It might not even be 1 million people. It might not even be 100,000 people. It's a relatively small percentage of the world's population. And if you go on Wikipedia, guess what? There's pages that describe every model they ever made, and all the changes that were made from year to year, and all this other stuff, and links to press, and books, and all this other kind of stuff. Well, where did that come from? It came from some other people in that small group of people that you're a member of who are passionate enough about that topic to post it on Wikipedia and attempt to ensure that it's accurate. And they're the people, meritocracy, just like we talked about before. They're the people that review changes. So if you go in and say, hey, I don't think that's right. I think that model was actually made until 1984, not 1982. And then you click edit and you make a change. And it doesn't actually change directly in Wikipedia. It used to a long time ago, and then it got abused really badly. So now most page edits are moderated, and it goes to someone, and they look at it and go, huh, what's your source? Is this just something you believe to be true, or can you send me a link to something that shows that this is true? Maybe you have an owner's manual from Renault from 1984 that shows that you, whatever, and they go, oh, cool, all right, thanks. And they'll update it, and they'll add a reference in there to say, this information was updated due to blah, 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 and hopefully there's an online reference to wherever that came from. It's exactly the same thing. Totally different field of endeavor, but it's exactly the same thing. There are people who spend every waking moment they can managing and editing Wikipedia pages in some field of interest, some area. And if you go look at, pick something random, it's pretty easy to do on Wikipedia because you just, what is it, there's the Wikipedia game, you go type in some random search and then you click like the 4th link in the page and then you click the 4th link in the next page and you click the 4th link in the next page. And I think if you do that 5 times, you end up on psychology or something. It's crazy. But if you go pick some area of interest and you go look at the revision history for the pages, you'll see some names, and you may see a few names that pop up a lot because those are the people that are moderating all the changes. And then you click on one of their names and you look at all the pages that they are either the authors of or one of the editors of, and there will be hundreds of pages that those people have some responsibility for. Not because anybody ever gave it to them, but because they earned it, because they were the ones who made sure that they were right. Just like open source software, just like open source theoretical objects. And then this is one of my favorite ones. How many of you ever heard of OpenStreetMap? Probably not going to be anybody, a few. It's becoming interesting. It wasn't interesting, very interesting at the very beginning. Probably everybody here has at some point in their life, possibly even today, maybe not today, recently, within the last month, used a GPS-assisted navigation device that helped you get from one place to another. Might have been software on a phone, might have been a dedicated device for that purpose, might have been software on your laptop or web, whatever, something along those lines. So you understand that obtaining the information about where you are in the world is not particularly hard anymore. GPS receiver devices are pretty inexpensive and low power. They weren't always that case. They used to be big briefcase things. Now they're tiny chips that you put inside other machines. So figuring out where you are in the world is not particularly hard. Figuring out what direction you're moving and what speed you're moving is not particularly hard. It requires an accelerometer and some math, which is not a particularly difficult thing to do. So you can figure out where you're located on the surface of the Earth, roughly, or even quite accurately, and which direction you're moving, that's great, except that only tells you latitude and longitude and a vector. That's not useful if you're trying to get from this conference center to your hotel because, well, that's not going to work. So the way that happens, of course, is there's a database. Someone has produced a database that contains all of these things: roads, buildings, freeways, on-ramps, lakes, parks. I mean, just everything. They have all these things that have to be on there. And they're all described very accurately, what points on the globe they cover, and a lot of other information about them. If they're roads, how they connect to each other, and speed limits, and how many lanes they are, and all this other stuff. Now, most of the raw information for those databases is actually freely available. Because, for example, we're in Bellevue, right? Bellevue's a city. That means the Bellevue city government, almost guaranteed, has a complete, accurate geographic information system database of every road and building and everything else that's within the city limits. They have to. They have to be able to do taxing. They have to be able to do repairs. They have to, just all kinds of reasons they have to have that information. And because they are a government, at least in the United States, and this is true most places in the world, that data is actually freely available to taxpayers, or to actually almost to anybody. If you have to go ask for it. And you might have to pay some nominal fee for getting copies of it. But it's free. The data is not protected. It's not held behind some license that says you can't have a copy of it. You can have a copy of it. But just think about this area. Just on this side of the lake, there are half a dozen cities that all adjoin each other. And then on the other side of the lake, there's Seattle and a bunch of other ones. And then you go, every one of them's got their own databases. How many of you would guess, well, no, I won't say it that way. Do any of you think that they all have the exact same database format? Of course they don't. Even if they're using the same software, it's different versions, and the database format is different. So could you actually go ask for a database from every government that has one in the United States, which covers nearly all the United States except for areas with very low population, but you're not going to be very interested in those because there probably aren't roads there anyway, so there's a good chance you're not going to be driving there. If you got all of those, would you have a big comprehensive database that covered the 48 states of the continental United States? Well, yes, you would, except it wouldn't be useful because you have 17,000 or some even larger number of databases, none of which actually you can connect together. So there are companies that do that. They go around and gather up all this information, and they also gather information on their own. Obviously, Google does this. There's Nokia, although I think they may have sold it now, had an app called Here, a database called Here, a company called Here, which used to be called Navtech. Anyway, there's 2 or 3 companies that do this. They go gather up all this data. They do all the massaging to get them in the same format and stitch them all together so that if you're driving on a road and you're crossing a city limit, your device knows you're still on the same road, but you've just crossed from one city into another and all that kind of stuff that's very useful to you for navigation. And they sell these things. Now they sell them, they can get away with selling them and getting people to pay them for them because the value of having all of this data mashed together in a format that makes it useful is something. It's actually worthwhile to you. Otherwise, your navigation device wouldn't be very useful because you wouldn't have any useful maps. But there are people who say, well, we shouldn't have to pay for it. I mean, all the original data was free, and we should be able to find a way to do this. Thus was born the OpenStreetMap project, which was born in Europe, but it now covers a great part of the globe. And this is just like Wikipedia, for example. The vast majority of the data that's in OpenStreetMap was put there by volunteers who wanted that area of the map to be accurate because maybe they live in that area and they want the area around where they live to accurately represent the roads and the buildings and everything else that might be there. And so now there are actually, for example, Android and iOS apps that you can use to do GPS-assisted navigation that use data from OpenStreetMap. You can actually do it completely for free. The app is free, and the data itself is free of cost. In addition to being freely licensed, it's also free of cost, which is not true for the other apps, or for the other databases. Interestingly, again, just like Wikipedia and Thingiverse and open source projects in general, what do you think is going to happen When someone who lives, I don't know, nobody seems to live right around where we are because this is all like commercial stuff, but let's say someone who lives, 10 miles away in a residential area notices one day that their town or their city is about to open up a new road. They've just extended some road. Maybe it goes 1 mile further than it used to, right? This kind of thing happens all the time. New roads are being built, or roads are being rerouted, or they're being changed, or whatever that's going to be. And if their navigation device knew about that road extension, it would save 5 minutes off their drive to work, because now they could go that way to get where they're going instead of having to go around some other way. And being a motivated engineering type person, it really pisses them off that their navigation device won't route them that way, even though the road is right there and perfectly usable. Now, if they're using a commercial map database, eventually they'll get an update to their map database that incorporates that road. But it might be 3 months or 6 months or a year. On mine, it's about 9 months or so, which is very frustrating. It's especially frustrating when it's not something you use on your daily commute. It's something that you use on weekends when you're going out random places you've never gone before. And the road change that happened is a road that used to be two-way is now a one-way road, which means you can't go that way anymore to get to the freeway, for example. And yet every single time you ask your navigation app to route you somewhere, what does it do? It sends you down the road and tells you to turn right. You can't turn right there because it's a one-way road now. So what do? Well, if your device uses this map, you go create an account here and you fix it because you can, because it's all right there. Same thing with Wikipedia. Source code is right there. It's actually, you don't edit the source code, but it doesn't matter in this case. Tools, web browser, internet connection, etc. Experimentation time, same thing. If you make a change, you can see it right on the screen. You can see that this road has now been marked in the database as one way going this direction, as opposed to being a two-way road. Just like Wikipedia, it has to be reviewed by someone. You can't just make whatever changes you want to the map and then have that downloaded to everybody automatically. That would be kind of too much power for anyone to have. But as soon as it is reviewed and merged, you can update your device right away because it's a database you can just download. Same exact thing, again, completely different field. So I think I'm probably over time. So I'll go through the rest of this really quickly. So that was kind of an overview of what open source means from a very broad viewpoint. It's not just software. It's actually philosophy and methodology. It's a way of collaborating. Excuse me. That's empty. All right. It's a way of collaborating. It's a way of, it's a mechanism that allows people to share a common interest in something being better, a way to actually achieve that without having to go form a company and find investors and all the other things that you might have to do to accomplish that. But as I mentioned throughout the talk, it's also a way to expand your own skill sets. It's a way to be able to demonstrate to some other party, whether that's a potential employer or another project that you'd like to participate in or something, history of things that you've done that have been valuable to some group of people. And so this part of the presentation I'll go through really quickly because I think we only had a couple students here anyway, but this is something that I generally recommend for students who are in college, which is to look for events called Open Hatch events. They are a group of people that actually are funded by the Open Source Initiative that run basically usually Saturday events to just help students get familiar with how you interact with an open source project. So all these students are already aware that open source software exists and all of our phones have it on it and all of our laptops have it on it, most of our laptops have it on it and all that kind of stuff. But the confidence hurdle that you have to get over to be willing to even try to participate can be very high. And it can vary a lot based on the project, but because people know that there's a lot of skills they may not have and they've heard about it being difficult to contribute to open source projects, a lot of people won't try. The purpose of these events is say, no, we're going to show you how to do it. So within a day, they help people download the source code for some project, teach them how to use basic version control, which is Git now, it used to be something else, how to compose patches to be sent to a project, how to interact with the people in the project when code reviews come back and it turns out that the way you did something is incomplete or wrong or whatever, and you want to work to get that better. So that's a really cool thing. For people who are students, there's something that Google runs, which has now been running for 11 years, I think, called the Google Summer of Code, where they take applications from open source projects to be part of the project, to be part of Google Summer of Code each year. It's one time a year in the Northern Hemisphere summer, not in the Southern Hemisphere summer. And they basically put a large pile of money towards giving students a way to work on open source software as a summer project and earn money, as opposed to whatever, working in a Starbucks or working in McDonald's or wherever else they might have to work to earn $5,000 or $6,000. And this is really interesting because it allows students to work in an actual project, do actual work, things they can put on their resume when they graduate and are off going to look for jobs. It gets work done in projects, and it is phenomenally successful at producing people who want to continue participating in the project. And if they continue participating in the project for a couple of years and then they graduate, a lot of big open source projects have corporate, I won't say sponsors, but they have big companies who are very closely associated with them in some way. Maybe those are companies that produce services around that software or whatever it is. Guess whose names are going to be on their list of people they might want to hire? The people who they've been watching for the last 2 or 3 years do successful projects every summer in helping to improve that software. This has actually become a good funnel for ways to get people into that. There's another one. This one is not focused on students, but it is focused on what you call underrepresented communities in technology, which covers a lot of things. It's women, it's minorities, it's all kinds of different underrepresented communities. And this one is very similar, except it's twice a year instead of once a year. It doesn't require you to be a student. It does require you, though, to work full-time on the project that you're going to be working on. You also get paid, I think, $5,000 or $6,000 for the 3-month project, or slightly less than 3-month project. Just like Google Summer of Code, it's an open source project. You have a mentor helping you along, plus all the rest of the people involved. But another interesting aspect of this one is it isn't just software development. There are people who've gone through this program that were graphic artists, and they helped an open source project completely redo their website and come up with new logos and all kinds of things, and ended up, in one case, actually being hired by a company to do that full time after they finished their project. So this is a really cool thing as well. So I'll summarize because I'm over time. All of this whole thing should motivate you to want to participate in open source projects, whether they are software or not, for these reasons. You want to learn these skills. If you don't already have them, especially if you're in college and you haven't graduated yet, you mostly haven't had the opportunity to learn them yet. These are real-world skills that employers want you to have. They want you to be able to work in teams and deal with code review and do release management and all this kind of stuff. And that's that. So thank you very much. I'll be happy to answer questions. I'm sure the video can end. And there you go. Thanks. And I don't need this anymore.